Hello guys, welcome back to the Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. Today we are going to discuss a very important lecture on that why we use steel bars in the concrete. That why the concrete needs the reinforcement or the steel bar. So in this lecture I will do some examples to clarify the concept behind the reason that why the concrete needs the reinforcement bars. So the basic purpose of the steel bars that are used in the concrete is that the concrete is strong in compression but weak in tension. So that's why we use the steel bars, because the steel bars have a high tensile strength and they are more resistant to the tension. So that's why steel are going to be used in the concrete to take the tensile stresses of the concrete, because concrete cannot take the tensile stresses of the in the structure. So steel bars will be able to take the tensile stresses of the structure member, and the tensile strength of the steel bar is more than the other material, like we can say about the timber, the glass. So that's why the steel bar are used in the concrete, not the other material like the glass and the timber and other material. So now coming to the example, this I will take an example. These are the two columns C1 and C2, and this is the beam, and I want to show you that how it bends and how we can say that the concrete needs the steel bars. So upon loading of this beam, and the load acts on this beam, this is considered a uniformly distributed load act on this beam. So this beam will try to bend now. Will try to bend, and it will show the bending like in this way, right? So this is the bending path of this beam. So now what happens here, if I draw the cross section of this beam, draw the cross section and draw the stress diagram. So here we can see at the top of this beam is compressed here. You can see here this is compressed at the top. Now as you can see that the upper portion of this beam is compressed and the bottom portion is extended, like it is in tension. It is tension in this portion, the bottom portion. Like if I consider my hand this, upon loading, the upper portion is compressed here, but the bottom portion here is tensioned, is in tension. So it as in tensile stresses created at the bottom, while the upper is in compressive. So I can draw here this stress diagram that the upper portion of the beam is in compression. There is a compression zone of the beam, and this is the tension zone of the beam, right? While at the middle we have neutral axis where there is nothing in compression and tension, and this axis, this is the neutral axis of the beam. So what happened after the loading, the compressive and tensile stresses creates in this beam, and due to the concrete weak in the tension, there are some cracks, flexural cracks creates at the bottom of the beam. These are called as the flexural cracks. So because concrete is not able to take that tension, and it takes the compression very well, but it doesn't resist the tensile stresses, so the cracks propagates in this beam. So what we do, we place the reinforcement or the steel bar that have the high strength, high tensile strength. So what happens when we place the steel bar here in this beam, like this way, if you place the steel bar, so now it will again bend somehow, but the stresses now which creates, like these were the openings of the stresses. So when we place the bar perpendicular to these cracks, so cracks will now not produce, because the cracks produce in this direction, and we have placed the bar in this direction which are perpendicular to the cracks. So the cracks will now not produce in this beam, and steel bar will be able to take the tensile stresses. These are the tensile stresses here. So the steel bars will be able to take the tensile stresses, and there will be no such flexural cracks in this beam. However, there may be some cracks, but not as much as that we have when no steel bar. So this is the one example that why we need reinforcement, because here the tensile stresses creates, and steel bar are the only material which have high tensile strength, and it can resist the tensile stresses very well, so that there will be no cracks produced in the lower portion of the beam, because this portion is in tension. Now the other example is, consider this is any retaining wall. I will consider this is any retaining wall with this footing and this is the retaining wall. So retaining wall, there is some soil pressure maybe because of the retaining wall are used to resist the soil pressure. So due to the soil will exert some pressure in this direction on the retaining wall, right? So the retaining wall will show bending like in this way. It will show bending in this way. So this portion will now show compressive. This portion will be in compression again, and this portion will again be in tension because of the load acting on this portion. If I consider my hand, if this is the load acting, so this portion will be in compression while the bottom portion will be in tension, while the below portion is not going to bend because this is the footing resistance provided to the bottom portion. So this portion will not bend. Only this portion will bend and this portion will bend. So the compressive stress is here and the tensile stress is here. So again, if there is no steel bar, so the cracks will produce in this steel bar like in this way. So what we do, we place here the steel bar in the retaining wall. So what happens when the load comes on the retaining wall, these steel bars will be able to resist the cracks and to resist the tension portion, and the cracks will not be produced in this portion of the retaining wall, and it will be able to resist the tensile stresses. So this was the main reason why we provide the reinforcement bars in the concrete. Hope you understand this video and subscribe our channel for DD7 engineering videos. Thank you for watching our video and share my video with your colleagues.